With this particular model, we have developed an exponential smoothing, and we're going to try to find the alpha such that it minimizes the error and makes this a better fit, okay, for this type of model. So this is for simple exponential smoothing. So to do that, we're going to go to the Data tab, and if you don't see Solver, we're going to need to add that. So go to File, Options, Add-ins, click Go, and then we're going to hit the Solver add-in and click OK. Take a moment to populate. There's Solver. So once it's available, click it, and we're going to do the following things. Our objective function in this case is we're going to want to minimize the mean square error. So F2, we're going to minimize it. We want as small as error as possible. We know we're going to be wrong, but we don't want to be very wrong. We're going to do that by changing alpha. So by changing will be F1. And we need to set some constraints up in terms of what we want it to do. So in this case, we can uncheck making it non-negative because we're actually going to force it to be between 0 and 1. So I'm going to add F1 is going to have to be less than or equal to 1. Then I'm going to add F1 also then has to be greater than or equal to 0. Click OK. And both of those constraints are now in there. GRG nonlinear, since this is smooth nonlinear as demonstrated by the graph in the sense that it's relatively smooth, but it's not, it's got trend and seasonalities we did in earlier videos. So we'll keep it at GRG nonlinear, and we're going to do solve. And then you'll see that it did indeed find a solution. If you did put everything in correctly, you can return to the dialog. If you check that box, you can do reports in terms of answers, sensitivity analysis, or limits to see what Excel exactly did. You can save the scenario with the scenario analysis, scenario manager. Here I'm just going to click OK. And with this alpha, let's make it to 2 decimal places. So alpha, instead of being 0.25, is now 0.62. And you can see it does a better job. It's not perfect, but it's better, much better than what it was before. Okay. So that is the simple exponential smoothing model using Solver. In the next video, we'll talk about a linear trend exponential smoothing model that will try to fit it even better, adding a couple more variables, and we'll use Solver once again.